brace ourselves, because this one's a classic. This is a 1950 Martin D28. What more is there to say? This is perhaps the most quintessential and influential guitar design of the 20th century. The early examples are highly sought after, of course. This is your bluegrass canon. This is your folk or rock balladier's sidekick or muse. It's your collector's dream. So the D28 proper was introduced in 1931. It had an antecedent, though, in the Ditson Model 111, or 111, of the late 19-teens, which was produced by Martin for the Ditson Company with this great big body, lots of depth, serious bass response. But the design took a while to gain traction, because this looked odd to most people who were used to parlor-sized and shaped guitars. However, once it took off, it really took off. No herringbone purfling. No, not on this guitar. That went away near the end of World War II, as did the use of scalloped bracing. These things you pay a premium for in the various retro-focused reissues, but at the time, herringbone marquetry sources in Germany had other things on their mind and weren't accessible. And the scalloped bracing could make for a few more warranty repair issues than Martin was comfortable dealing with. So they decided to strengthen things slightly by getting rid of it. No herringbone, but this does have the serious Brazilian rosewood for the back and sides, which are in exceptional condition. Brazilian, as I've mentioned before, is very prone to cracking. Sometimes even in what might be considered optimal conditions, it just sort of has a mind of its own. But this guy survived. The Brazilian lasted until 1969, then supplies got unreliable. They started using Indian rosewood, which is also a very nice tone wood. So what's it need? Not a whole lot, I don't think. It's mostly in for preventive maintenance and care and attention and a little bit of love. This is Dad's guitar. He unfortunately can't play it very much anymore, so they're trying to make sure that it's looked after right and nothing bad's ever going to happen to it. I believe this guitar's had a neck reset. There are clues. The fretboard has been glued back down to the soundboard without a wedge under the extension, which is an aesthetic choice. It's nice when that can happen. Sometimes, depending on how much the neck angle had to change, it's impossible. But it is nice if it can go back down again without issue, because it looks less altered, right? However, there are often issues that pop up in the aftermath of that, those issues being frets. And the result can be buzzes and notes choking out, because bending the board down into that angle can be asking a lot. I think one of the primary things to address is after that neck reset, this thing got a new saddle, much taller than it had previously, I imagine, and it is leaning forward quite a lot. This can cause various issues, of course. Depending on the amount of lean, we can end up losing valuable string length, and then tuning issues arise. Earlier this week I ran into a guitar that had some issues around that, so let's maybe take a look. Here is a Norman guitar, Canadian made, one of the Godin brands. This model happens to be a Protege B18 cedar, which is kind of interesting. Laminated back and sides. It's got a Fishman electronics package in it. The cedar, however, it's a cedar topped guitar, but they've added a veneer on top of the cedar. It's a little unusual, because that seems to be a solid cedar top in there with this thin, 20 thousandths veneer glued to it. The veneer itself looks like it might be ash, fumed ash or something. Haven't seen that before. And the funny thing is, looking at the grain lines in the cedar on the sound hole edge there, it looks like it's actually a pretty tight old growth cedar top, so maybe it had a bunch of colored, strangeness going on. People don't like streaky looking guitars, so they put this on top. which is an extra step in the process, and I think you'll probably strum right through this in quick order. However, the idea is to get this playing as well as it possibly can. The owner is most concerned with the state of its intonation. The top 3 strings play okay, but it gets progressively sharper as you move down towards the bass, suggesting that maybe the saddle slot wasn't cut in quite the right slant. We might have to reroute that depending on how bad it is. The action is not too outrageous, just under 6/64 on the bass side and about 5 on the treble. But the relief in the neck is something else. It's 19 thousandths. That's pretty extreme. I measure that with a capo on the 1st fret, and I hold down the low E at the body joint using a feeler gauge at the 6th and 7th frets. And 19 thousandths is like 3 times what it should be. Here's the thing. If a neck is really bowed, the actual string length can be affected because it folds up into a C shape, and the saddle and the nut actually get closer together by a small amount, but that small amount could rob us of the required compensation length in the string. Basically, it ends up putting the frets in the wrong position for the effective scale length. So whoever set this up didn't know about truss rods. They have taken the saddle height to a very low place without adjusting the neck relief, which leaves us with a guitar that's quite difficult to play in the middle positions of the neck, and there's not a whole lot of downward pressure on the saddle, so we get that sitar-like buzz. This is not a fret issue. There's plenty of clearance for the string. So first things first, I'm going to adjust the truss rod here. This appears to be a 4mm, and see where we are. Doesn't feel like a whole lot of tension on that rod. Why does it feel like I'm loosening this rod? Hopefully it's a double action and it's been pushed in the wrong direction. Okay, now it's starting to get tight again. So this was actually put into reverse. Okay, that feels snuggish. Okay, so the relief is now about 6 thousandths of an inch. We'll see how that plays. We'll talk about double action truss rods. Number 1. The original truss rod is simply a length of steel that's captured in the neck at one end through some means and threaded on the other for a nut, which, when tightened, forces the center of the neck upwards, counteracting the bending force of string tension. In order for these to work well, they really should be installed in a curved channel with a corresponding curved filler piece above, which is not the easiest thing to make. Gibson introduced this kind of rod in the 1920s, Fender adopted it in the 50s, and by and large still uses it even today. Later on in the 1970s, the over-under rod gets into play. In many cases, this is a single rod that's bent double on itself with one end captured on block and the other end which is free and threaded for the usual kind of nut. This one has the advantage of working in a straight channel, which is easier to produce. Finally, there's the double action or dual action rod, in which the adjustable end passes through a hole in the capture block which has been threaded, and the nut is welded in place on the end of the rod. It's non-removable. So if you turn this one way, you can remove back bow like with a standard truss rod. But if you turn it the other way, you bend the neck in the opposite direction, forcing more relief into it. Is this ever necessary? Very, very rarely. Some necks do have internal tension that makes them want to warp into negative relief, but it's so rare that I can only remember 2 instances in my work where that was the case. In the vast majority of necks, even if you're using ultralight electric strings, there's enough tension there to pull a straight neck into a slight amount of relief. So the primary function of this kind of rod is to confuse players into bending the neck the wrong way. Okay, with the big adjustment, the action is now below 4/64 on the bass side, and just about 3 on the treble, which most people are going to think is too low. Sometimes you can get away with it if you've got a really stable guitar and someone who doesn't mind some buzzing, but it's okay. Straightening the neck has also sort of exacerbated the sitar effect. There just isn't enough break angle. Have a look at how loose the saddle is in the slot. It's pushed up against the front edge. Now this has, of course, the under saddle pickup in it, and with those you can't have a really tight saddle, unfortunately. You end up losing quite a lot of sound transfer into the bridge because of it, but you need the sort of downward pushing effect into the piezo strip to activate the pickup. However, I think that might be too loose, and we got an extra 0.5 millimeter of compensation there. The other thing is, yeah, not enough downward pressure, so we're going to end up making a new saddle to raise the action now a little bit, and hopefully develop a bit more break angle. I'll point out that this bridge is only about 1/4 of an inch, just over 6 millimeters tall, which for a factory instrument is pretty low. And there's a lot of to and fro wobble room for this saddle. In fact, the saddle is over 25 thousandths of an inch, which is more than 0.5 millimeter narrower than the slot. So the new saddle is going to be about 2 thousandths of an inch undersized. So rather than the optimal fit, which you see here where I can lift the instrument off the bench, yet still remove it with finger pressure, this one is going to slide right in with very little wiggle room. I'll also take some time to extend the string ramps towards the back of the saddle. This will increase the break angle by moving the point at which the string leaves the bridge closer to its destination. The low action, of course, reveals some high spots in the fretting towards the body joint, which need to get taken care of. Note that in this rough stage, the bass strings are taking off at the very back edge of the saddle. Well now, I started thinking, and I started measuring. So I wanted to compare the scale length with the actual string length that we have here. So double the distance to the 12th fret plus the required compensation factor, which I got off the StewMac site. And this is right on. It's bang on. And yet somehow those low strings are still playing exceedingly sharp, like 25 cents worth. But it occurred to me while I was doing that, I looked at these strings. The low E seemed a bit skinny, as did the low A. And they both seem to be about the same size as the D, which, you know, that's unusual. So grab the caliper. Turns out this low E is around 37 thousandths of an inch in diameter. And the A is about 35, which, that's unnatural. So, you know, it's 20% thinner than what it's supposed to be, even on the most extra light set, like a 10 to 47. These are much too skinny for the required pitches. The owner purchased this guitar recently, and I imagine that these are the strings that came with it, and I think someone was just using up orphan singles without any regard for what they have to do. So, ever wonder why guitar strings are of different diameters and that the bass strings are larger? It has to do with having enough tension at a certain pitch and a certain mass in the string. So if we take a lighter gauge string and tune it to a low pitch, well, first of all, we end up with a very floppy feel. And coincidentally, we also need a lot more saddle compensation to make it play in tune or intonate. So, let's get a proper match set of 11 to 52s on this thing and see what it does. Yeah. Okay, all set up. Action is good and low. Ready to play. Other problems can arise from a leaning saddle, most especially if it's a through saddle, and even more if it's tall. That can exert a lot of pressure on the front section of the bridge. If you look down here at the treble side, you can see there's not a whole lot of material there in front of that saddle. And these have a habit of cracking right through and breaking off. Looking at this witness line in the lacquer that's just ahead of the bridge makes me believe that it was probably replaced at some point, taken off and re-glued. Now again, it's important to differentiate between a saddle that's actually leaning versus a bridge that is pitched forward due to excessive soundboard pull-up or bellying. Now, this guitar exhibits what I consider a normal amount of deforming back here. We expect to see the bridge roll forward some. These are still fairly lightly braced guitars, and it's going to happen. Another thing that can happen, depending on how the saddle was shaped, usually, when it leans forward, it can present a wider surface area for the string to take off from. And that can lead to an unfocused, blooming, sort of sitar-like sound, because the string will start to vibrate and beat against the flat area in front of its actual takeoff point. And that's what's happening here to some extent. Something to note is that these through saddles were originally glued in. That's important. It stabilizes the saddle in the slot, and it kind of works to hold the bridge together. So you got these two distinct areas with a channel down the center. They kind of want to yawn apart. If it's glued, there isn't the opportunity. Modern guitar techs often don't want to do that because they perceive it as maybe limiting their ability to adjust the action, but it's just not true. Due to their shape, with the ends of the saddle tapering down to match the radius contour of the wings, you can't treat them like a modern drop-in saddle, because the height adjustment has to come from the top. If you sand material off the bottom, they end up getting narrower, and they end up narrower than the slot, which might be okay functionally, but they look weird if you're not used to seeing them in their proper form. The other thing the glue does, especially if it's a protein-based glue like hide glue, which gets really crispy when it's dried, it's almost glass-like in its hardness, is that it marries these parts together in a way that really accentuates the energy transfer. There are those who contend that this is a big part of the Golden Era sound, having a glued-in saddle. A plucked string is a terribly inefficient way to excite the soundboard. Something like 95% of the energy is lost, and most of that is actually heat, if you can believe it. So having that solid connection between the parts goes a long way towards preserving what energy there is to work with. Yes, it's annoying having to file the top of the saddle if you want to make changes, because you have to try and preserve the radius, but in the long run it's much healthier for a through saddle guitar if it's glued in. So we have some unfocused sound. You can really hear it on the B string. To a lesser extent on the E as well. There's also some little buzzes happening around the body joint. We'll have a look at the action. Just over 6/64 on the bass side and 4 on the treble. So the bass side could come down a little bit, I think, but it's doing pretty well if the neck reset is like 13, 14, 15 years old. Neck relief, measured at the 6th fret with a capo on the nut end and my finger depressing the string at the body joint, is around 6 or 7 thousandths. Don't mind that at all. That's pretty good. Original frets could use a bit of a cleanup. There's some denting happening, especially on the B string. With a little bit of recrowning, we might be able to limit that a bit. At some point this guitar had a sound hole pickup installed. There seem to be 2 little plugged holes on either side of the rosette rings. which may be an early dearmament or something like that. There's further evidence down here at the butt end. There is a plugged hole, which we surmise used to have the cord from the pickup. Must have been an integral jack style cord, because this is only about 5 millimeters in diameter. We're currently missing the strap button. I'm going to try to put a new one in there for him. The only cracking on the whole guitar are a few little guys back here behind the bridge, which is slightly unusual. They don't go very far. They don't meet the outline or anything. I guess they kind of stop where the upper tone bar is, which is kind of nice when that happens. These appear to have been glued up. Why they would appear right there is kind of a mystery. And like virtually every Martin built before the 1970s, this has got a pickguard crack, which appears to have been glued up previously. This happens when the celluloid plastic, which is adhered to the soundboard, shrinks, and the spruce can't handle it. It tears open, basically. Usually it'll be here, or it could also be on this side. This has got the tuners that look like, well, little toasters or something. This one's got a bent shaft. Time to look inside, and there's a surprise. The bridge pad is not original. It's the right material, which is maple, but it looks much younger than it should, and the grain direction reflects some modern ideas. It's cut on a bias, or diagonal, rather than straight through the pinholes. It's also slightly larger than vintage, not a whole lot, but a little bit. So it takes up more area, and it's thicker as well. This would explain those cracks behind the bridge. It's possible those happened during a particularly violent removal, but why that should be, I can't speculate. The thin little maple pads tend to come out easily in comparison to something like a late 60s Gibson. There's one more surprise, though. I turned off my inspection light, and I saw this amber glow. Now please understand, I don't have my desk lamp focused on this spot. This is just the ambient overhead light in my shop. Yee. It's localized and it's very thin. It's probably down to a 1/16 of an inch, maybe 1.5 millimeters. And the soundboard, it seems to have been sanded. Again, this could happen if someone tore a whole bunch of wood out while trying to take out the original bridge pad, but this is so thin that I think it's a cause for worry. Because this is a sensitive area where the humping happens and where the torsion from the bridge is at its most. I've got some little circular magnets which I can use to plot out the position of the back of the bridge plate and the diagonal tone bar. This will help me make a template for a shape that will fit in there nicely. Going back and doing a bit of palpating, it's kind of amazing how spongy this area is. Got some old spruce, which I'll cut out. Got some old spruce of similar quality. I'm cutting this so the grain runs parallel or in line with that of the soundboard rather than across like I would for a regular repair cleat. I'm just looking to re-establish the thickness there, not stiffening it beyond its usual parameters. I'll super glue this down because it's small and going to be exceptionally thin, and this is the most stable way I know of holding it. And I'll just plane that down to about 1 millimeter thick. I also cut a caul and padded it with cork because the area it will be glued to is bound to be undulating and scooped, and I want a compressible backing to help force it into contact. I've rehydrated some hide glue, which is basically a nasty form of jello. When I heat that up in my double boiler to 150 degrees, it becomes liquid, and I'll warm up the part because this will give me a little bit of extra working time. Hide glue sets very fast. So I got the patch in position and then quickly slapped on a couple of clamps. And that took care of the thin spot very nicely. It's been a while since this fretboard has been cleaned. I'll map out the areas where there are high frets. The 14th fret is pretty high, as expected. I'll make sure the high areas aren't caused by a sprung fret. Make sure they're tapped down and secure. No, it seems to be shifting in the wood. I'll dress things back down into levelness, then do some recrowning. Then everything gets a polishing. Turning to the saddle, I'll measure the amount I'll want to lower the base E string, grab a radius gauge, and give myself a line to work to. In this case, I know that all the strings except the B are going to take off basically at the very front of the saddle, so I have to file it into a shape that will allow them to do that cleanly and minimize vibrations. It's time to replace the reshaped saddle, and I'll be gluing that in with a little bit of fish glue. That makes it fairly easy for it to come out again. Just heat it up with a little bit of moisture, and it'll come out cleanly. Going to pop in a strap button, but it needs to be resized. I'll take one turn of the reamer just to make sure the hole is good and clean. This is a violin peg shaver. That produces a good snug fit, which won't accidentally come out. And there we have it. An iconic piece of American musical manufacturing from a great period in its production. Sometimes these things really do live up to the hype.